We're going to talk about eigenvalues and eigenvectors. So in linear algebra, we introduce different topics, different mathematical objects. One of those are eigenvalues and eigenvectors. Where you see the application, for example, in machine learning and deep learning, one of the techniques that they apply is PCA, or principal component analysis. Component analysis, which helps to reduce the dimensionality of data set. So let us begin talking about eigenvalues and eigenvectors. We're going to start by a very simple definition. Suppose you have a square matrix. Let A be a n by n matrix. We're going to introduce a scalar, a number like lambda. The scalar lambda is an eigenvalue of matrix A when there is a non-zero vector like x such that with the condition that Ax is basically the same as lambda x, or you can solve this equation. This vector x is called eigenvector. It's called eigenvector. Just a quick note for you. Eigenvector cannot be zero. Why is that? Because you get A, 0 always equals to lambda equal to 0, so 0 is always equal to 0. It's 0 for all real values like lambda. So there is no way you can solve this equation. One example for you. This example says you have a matrix for matrix A, which is 2, 0, 0, and negative 1. Verify that vector x, which is given to you as 1 and 0, is actually an eigenvector. Verify that vector x equals to 1 and 0 is an eigenvector. I'm going to give you eigenvalue lambda as well. Later on, we're going to learn how to actually find this guy. So solution. Remember the definition. Always go back to the definition. Definition is super important. Since Ax must be equals to lambda x, take a look. My A is matrix 2, 0, 0, negative 1. My vector x is 1 and 0. Writing it this way, so the multiplication makes sense. It must be equals to lambda, which is a scalar, times vector 1 and 0. So left-hand side and right-hand side. Check left-hand side. Left-hand side says, hey, I have a 2 by 2 matrix. I have 2 by 1 matrix, so the outcome is going to be a 2 by 1 matrix. First row, first column, 2. Second row, first column gives us 0. This is my left-hand side. My right-hand side, hey, it's just a scalar multiplication, all right? So you get 2 and 0 back. They are equal to each other. So we just verified that. So what is the conclusion? we verified that the eigenvector x1 and 0 is corresponding to lambda eigenvalue